So good afternoon, folks. I'll just give it a couple of minutes, wait for people to join in, and then we'll get started. So guys, can somebody just put a comment in the chat just to let me know that the sound is working okay? Afternoon, the 3D FPA. Is the sound okay? Great. Yeah, I just needed to know that the sound was coming through okay. Good. How is everybody on this fine Monday morning, or Monday afternoon actually? This world is a strange place today. So I'll just give it a couple of more minutes and just see if anybody else wants to join, and if not, we'll crack on and go through sensorless homing. All right, so there's a couple of people on the stream, so let's get cracking. Basically what it is, I'm going to run through how to set up sensorless homing on a Skr1.4 turbo mainboard using TMC2209 stepper drivers. The actual sensorless homing configuration isn't really a big deal. There's not really a hell of a lot to do. The tricky thing is getting the stall thresholds and stuff correct in order for it all to work right. So I'm going to assume that everybody here already has a working copy of Marlin that's running on their machine, that everything else is configured correctly for your machine in specific. So I don't need to go through all of the setup on Visual Studio Code and how to bring the folders in and all that. I'm just going to assume that we all know what we're doing. Effectively, if you need to know how to set up Visual Studio Code, there are a couple of really good videos out there that you can go and watch on YouTube just search on Visual Studio Code. All we're going to look at today is, well, there's two things. There's a couple of people that have asked about dual Z stepper drivers so that you can use the Z auto align feature. So once we've set up the stall guard, I'll go back and we'll just run through quickly how to set up the dual Z stepper drivers. But I think the first thing we need to do is just make sure that we understand how this all gets connected up. So I'm going to switch over to camera 2 and we're going to have a quick look at the board itself. This is a spare board that I've got that's I'll just show you quickly to how to set up the main board in UART mode, where the stepper where the jumpers need to go, and obviously how you actually configure the stepper driver itself in order for it all to work. So in order to get the stepper or the jumpers correctly aligned for the UART mode, and the UART mode is basically going to allow us to, in effect, get telemetry back from the mainboard through G-code commands in whichever slicer, but I'm going to use Pronterface for today's example. So as you'll see, when you get the board, these sets of this set of header pins here will all have jumpers on them. And in order to set it up in UART mode, you have to remove every one of the jumpers but the one second from the bottom, and that's the only jumper, and you set that the same across all of the stepper drivers. In order for it to get stall guard working, there's a couple of things you either do or you don't excuse me, that you do or that you don't need to do. One of the things that, if you look at the Bigtreetech GitHub page, there's quite a good example of how this needs to be set up. So let's just have a quick look at that. In order to set the TMC drivers up in UART mode is what we're going to be doing. It says here, when using the TMC, if you do not use stall guard, you need to cut off the diag pin. Now, I'm not really sure what Bigtreetech were thinking when they did this, because it just seems an awful waste to have to cut off a pin on a perfectly working stepper driver. However, in order for this to work correctly, we need to do this. So think about what we're going to do. We're going to set stall guard on X and Y only. We're not going to set a stall guard on Z, because the Z is going to use a BL Touch or whatever probe you're using, and in this case I'm using a BL Touch. So we still want that BL Touch probe to work as an end stop. So we just leave that. So we need to cut off the diag pin for Z and also for E. I'm not really sure. I've cut it off for E. I'm not really sure whether or not you're going to be using it or not, or whether it makes a difference whether you cut that diag pin off on the extruder, but I've done it anyway just in case it needed to be done. So just to recap, if we're not going to be using stall guard, we're going to be cutting off that diag pin. So we're not going to cut off the pins for X and Y, because we're going to be using stall guard on those two drives. So that basically covers the stepper driver itself. Let's go back to the so I think let's go straight into Marlin, and then we'll dive in there and we'll see how to actually set it up. And if we've got any questions, please guys, just feel free to just drop us a comment in the chat, and we'll have a chat about what we're doing. So the first thing we're going to have a look at now is obviously is Marlin, and let's just dive straight into Marlin and have a quick look. So in order to set up the stall guard in Marlin, we don't really need to do much in the configuration H, except for making sure that a couple of things are checked, making sure that there's no inversion, that we've got all falses on the inversion, and depending on which machine you're using, of course. On the Sovol SV01, which we're going to be using today, this invert X drive needs to be set to true. because that's how this board is used. So just make sure that is set to true, and false for the invert stepper directions. There's not anything else in here that we really need to worry about. Just make sure that your bed sizes and everything are all correct. Software end stop pull-ups, make sure that software min end stops are defined. When we go to, and that's pretty much all. So those are just small checks that you need to do in the configuration H. Most of the configuration itself for sensorless homing happens in the _adv.h. Yes, Sam, I will post a guide. I've created a Word document, or a document. I'll just switch over and I'll show you quickly what it looks like. So this document here is basically a step-by-step guide which I've created, and I'll make that guide available in the comment section. It'll probably be a link to a GitHub website, but I'll make this available so that you guys can just follow along step-by-step how I got to doing this. So back to Marlin. So obviously we now know that I have, for all intents and purposes, I've already removed the end stop mechanical switches on my Soval. I've unplugged them. I've plugged in the stepper drivers for X, Y, Z, E and E1. The E1 is going to be for just running through how to do the Z auto align, just after we've gone through the actual function of how to set up the sensorless homing. Right, so the first thing we're going to go do is we're going to go look for sensorless homing, and you'll see there's a section that says define sensorless homing. So we need to make sure that that's defined, and I've mentioned it before in other videos I've done. That let's just quickly make sure that we understand what I'm talking about. So if those two comment lines, those two forward slashes are there, that function is basically switched off. So in order for us to switch it on, we need to take out those two lines, and that then, sorry, I've just taken that comment away, and then just, right, so also one of the things you need to make sure of is that the stepper drivers that you're using, this particular video or this particular live stream is going to cover the 2209 stepper driver, which for the most part a lot of people are using. But I just wanted to make you guys aware that if you're using a different driver, you need to make sure that your driver that you're using can or is capable of running a stall guide. Right, so once we've done that, we need to these two values here will be set at 8 initially when you first define this. And we're going to go back into Marlin, into the G code through Pronterface a little bit in a couple of minutes, and I'll show you that value can be set from within the G code. I'm just going to set them at 80 for now on both of those values, just simply because I know that there or thereabouts is going to be a good starting point. If it's not defined, comment off define this improve homing reliability, and that's that done. And then go to do a search for has Trinamics, and this is the section that will deal with whatever stepper drivers you have. Above that is for the TMC26 and all the various other drivers, but for this one that we're doing now, we're going to be using the has Trinamics just simply because we've got the 2209 stepper drivers. And actually, let me just go back for a second. I'm going to just jump away from here back to the configuration H, and we're also going to make sure that in this section here where it says stepper drivers, you need to make sure that you have an X, a Y, and a Z axis defined with the correct stepper driver. So just make sure that that's done correctly. Also, to define your extruder, make sure if you're using a different driver on the extruder, which I know some people do, is to make sure that that stepper driver, that particular stepper driver you're looking at or you have, is defined in this section here. Once again, we're using the dual Z, so I'm going to come back to this, and but if you're going to be using the dual Z, make sure that the Z2 driver is also defined along with its stepper, with the driver that you're going to be using. Marlin will cleverly understand that that Z2 driver will actually use the E1 pin to swap and create that as your extra stepper driver. Okay, so I digress slightly. Righty, so in this section here, there's a couple of things we need to do. We need to set the milliamp current voltage for each drive. I'm going to leave these all standard at 800. The caveat to that is, though, if you find you're having missteps, or if you think your motors are getting too hot and the stepper drives are getting too hot, you can then come back and reduce these voltages in this section here. The current is not so the X current, now there's a debate, and I'm not sure whether or not you actually really need this, because I've tested this without actually putting a value in here. Chris Wakaki showed me some files last night of his where he has got a value set in there, and I also had a working set of a working version of Marlin before 2.0.5 came out. And that's where I started to run into issues, because for some other reason, whether it be my fault or not, my Marlin started doing some really funny stuff. It started crashing into the end stop zone. I started having issues with false positives, and it just became really unreliable, and it was really inconsistent. It would work sometimes, and then sometimes it wouldn't. So I'm not actually sure what value this is, but I'm going to use Chris's values as a starting point anyway, just to see whether or not this makes a difference to how the actual sensorless homing work. Right, so we have X, we have a value in X. We need to put a value in Y, so we'll put in 200 there. On the Z, I'm going to use 200 again, just because I'm not sure whether or not this has a value or a it makes a difference, because like I said, I have tested this, and I tested it again this morning without actually having any values in there, and it still works without that value. So I'm kind of in a unsure of whether or not that really does work. So in saying that, I just want you guys to understand that I'm not exactly a Marlin expert, but I'm also doing this through trial and error, and as I'm going along, I'm also learning new things. So we'll just use those values there. On E, you'll see that defined current home is not on E, because we haven't got E is not going to be set up for stall guard, because it's unnecessary. As with a Z, in fact, on Z, I'm almost sure we don't need it, just simply because so I'm just going to leave those as are, because we're not using. And let's create that Z2 current, and then go up and do the same thing for Z current. And we'll just leave those values as they are, just simply because we know for a fact that those two values are not going to have stall guard on them, because we're using a BL touch probe. Further than that, we need to, in order for the stall guard system to work correctly, we don't want, I don't know if you've ever watched your printer when you're homing the X-axis or the Y-axis, it'll go and it'll kind of like bounce against the end stop. That's called the bump value. So in order for this system to work, we don't want a bump value at all for the drives that we set up with stall guard. So X home bump value is normally set to 5, I think. Set that to 0. And then again for Y, also set that to 0, and only can leave Z defined as it is. And that's pretty much it. As far as stall guard goes, that's the Marlin part of the configuration done. The next bit of the whole process actually starts to work in, you need to start working it. Hey, how's it, Golf? Welcome to the stream. Welcome to anybody else that's watching at the moment. At the moment, we're going through the configuration for setting up stall guard or sensorless homing in Marlin. So if the guys that have just joined, if you've missed any part of it, then I suggest when this is over, you can always go back and you can rewatch this video on Facebook as a recorded stream. Cool. So I think the next thing we're going to do is we're going to jump straight in and go and have a look at Pronterface and see how Pronterface works this all out. So once we've done all of our configuration in Marlin, just go to project, and depending on whether or not you've actually set up your environment or anything, just go to build and let that process run away and build. I'm not going to build this. I know it works. I've already gone through this process this morning just to make sure that I could get it to work. And now we'll go into Pronterface and go do some stuff in Marlin, just to make sure that once we've done the flash to the board, that everything is working correctly. So first of all, let's just disconnect from my printer, connect up again, and just to make sure that everything is kind of working okay, let's switch over to, I will go onto a camera view in a second just to show you how the printer reacts to certain commands and stuff. But once we've done the flash, the first thing we need to do is just go in, let's connect up, and then make sure that I've moved slightly to the left, and we know that the X moves. Let's move the bed plate. We know the bed moves forwards and backwards, and that's great. That means that things are working. I'm not going to heat up the extruder because I know that the extruder does work. But what I will do is we'll go into Pronterface. I'm just going to show you a couple of things to check out for. Two things that we need to check initially when we first do this is do an M. Let's do a M122. And that's going to go, and remember we said that we're going to set this whole thing up in a UART mode. So this UART mode basically allows us to check that basically if the guys that fly quadcopters and stuff, you'll know what it means by when I say to you that you can get telemetry back from the stepper drivers. Well, this M122 basically gives us some telemetry effectively, and it tells us what values we've already got. So we know that if you initially look at this, and sometimes it'll say false across all of them, but if you'll see that I moved the X gantry a couple of seconds ago, and that's then triggered that those values are true. I haven't touched Z, I haven't touched E, so those are false. But I did move the X and Y, and those then trigger and show me that they're true. It'll also show us on X, Y, Z, E, and whatever we've got those voltages set at. If we go, when I was setting up Marlin, I said to you that those voltage in the has trinamics section of the setup. So I'll just show you quickly. We'll go back there for a second just to show you. So these values here in that value there, that 800. So if you look in Pronterface, that section here will show you those values that we just pulled back from the telemetry. Another good thing to check is make sure that when the check comes back, that those connection settings or the connection statuses all say okay, because that's pretty important in knowing whether the driver is actually being connected properly and that they're actually getting some sort of value back. Sorry. So that you know that they're actually getting some sort of value back from the driver themselves. So let's then go into, so the next thing we can check is an 114 or M914, sorry. And that there is going to tell us those. Remember, we set up those two values when I said to you I'd leave them at 80, just because I kind of had a rough idea of where my machine would be working at. And then I slowly dialed them up and down to see where the happy medium was for my particular machine. And then also you'll see the stall guard thresholds. If you look at them there, you can see stall guard thresholds is giving you what they were. Obviously, we've got no stall guard on on Z, Z2 and E, but only on those two drives there. So if you looked at it from my point of view, so if I did a home all, and hopefully this will work. So and just because this is a live stream, so it's doing all sorts of weird things again. So this would basically tell me that the thresholds that I'm using are incorrect. So if that's trying to do a home, so, and that's homing completely in the wrong place. And this just goes to show you when you're working on, or when you're trying to do something in a live stream, how things can be totally different. A couple of hours ago, I had this working pretty well, and as you can see now, in a completely different area, which is fairly annoying. So yeah, it's super annoying. Okay, so let's go quickly and do a home and see what happens. Okay, so X has worked fine, there's no bump or grind, and Z has worked fine and there's no bump or grind, which tells me that those the stall guard values that I've used are correct. And we'll do a 914 again, and we'll see, that'll tell us which values I've used for my machine. So this is something that you really need to check. And this is something that you're going to need to play with in order for you to get your machine properly dialed in. There are I mean, you could start literally at a point in time, and I would suggest starting at 80 for X and Y, and then possibly, if you're getting a false positive, one of the things that you'll notice immediately if it's incorrect is if you click on an axis to do something and it doesn't move at all, then I would then either go slightly up until it starts moving, or go slightly down until it starts moving, because there's kind of a happy medium, and each stepper driver or each motor may be slightly different to somebody else's. So the settings I use in my machine may not necessarily work on yours. However, you have to have a point to start at, and I found that 80 seems to be a fairly reliable starting point, and then you can obviously go up and down from there, and you can dial your machine in to your specific settings. It can be a little bit frustrating because you're going to end up with a lot of grinding, and it just, you start to think, well, am I going to break something? And that was my fear when I first did this, and because of those false positives, it can be quite daunting, and the more you dial it up and down, it may become a little bit more frustrating for some people, but just stick with it is basically all I can recommend. But like I've said, the actual stall guard configuration in Marlin is actually dead simple. There was only a couple of things that we had to switch on, a couple of values that we needed to change, and those values were more around the current that the stepper drivers are going to use, and really importantly is to take off the bump value, and also to set the thresholds. Marlin when you start a fresh copy of Marlin, those bump values are on 5 on X, Y, and Z. Excuse me. So we just need to make sure that when we're using or when we're actually doing the configuration, start off at a point in time, and then, you know, go to, and then start to figure those things up and down. And I think, yeah, so I mean that's pretty much it for stall guard. If anybody's got any questions or wants me to go through anything else, just drop a message in the chat and I'll try to recap it. But like I said, there's not a lot to actually setting up the stall guard itself. It's pretty quick to configure in Marlin. The headache could start when you actually start to do the thresholds. So, I mean, while we're here, a couple of people yesterday asked me if we could just cover how to set up the dual Z stepper drivers. And like I said in the beginning of the stream, I've set up my board already that it's configured for the dual Z stepper driver. So basically you need to take a stepper, and put it into the E1, which would have normally been used for your, if you look at this, E1 would be this far side stepper driver here. And then because I'm not using stall guard on that, because I'm not using stall guard on Z, I've had to cut off the diag pins for both Z stepper drivers. I haven't cut them off on these. This is a new set of stepper drivers, but I'll just show you quickly which pin I mean. This pin over here, this furthest one closest to the black, needs to be cut off completely. And like I said in the beginning, I'm not sure what Bigtreetech were thinking when they did this, because there has to be a better way of doing this rather than destroying. Well, I mean, you're not destroying it. If you're okay with soldering, you can deepin the stepper driver, or some people have used things like nail polish, paint over the pin with nail polish, and it just acts as an insulator against it actually working correctly. But anyway, so obviously you just need to put in the stepper drivers on all. Make sure, and one of the things when you do these stepper drivers, to just once you've done it, to have a look on both sides that you haven't missed the actual holes. And it has happened that you can misseat them and they don't actually seat correctly. So then you just go away and you set up obviously all of the drives on Z. So X, that there, X, Y, and Z. So we'll put those two stepper drivers in the Z. So in order for dual Zs to work, we obviously need those two stepper drivers to be enabled. Marlin already has a bit of code in the background and knows that if I use that E1 and I define how many stepper drivers I have, it will immediately basically route those pins, or it ports those pins, and it knows that E1 is then going to become the Z. So let's just do a dual search in. We go back to Marlin for a sec, and then we can have a quick look what we have to do in Marlin in order for this to happen. So dual stepper drivers. If you just do a search on dual, it'll come to dual steppers and dual end stops. You'll see there's dual X, dual Y. Of course, the ones that we're going to be looking for are the dual Z, number of stepper drivers. So this value here needs to change. Stock Marlin will come out with one stepper driver. So the minute you've defined that second stepper driver, the logic behind the scenes and how Marlin actually works kicks into action. And then Marlin already knows intelligently that that second stepper driver is going to be ported to E1, which would have been the second extruder. But for this case, we'd be using the dual, so that's that. we also then need to make sure that in the configuration.h, and I went through this just now, is to know that we're going to be using the second Z driver. Marlin, you would normally, if you were only using the one stepper, you would define XYZ and 10, E0, sorry. But you need to define that Z2 driver, and that will be what ports the actual pin to where that stepper driver is going to be working. Then we need to go back to configuration_adv.h, and again we're going to go back to the has trinamics, and when we switched on that 2, the number of stepper drivers equals 2 at the top of this file, it's going to then switch on the second axis here. Normally this would be grayed out and you wouldn't be able to edit or do anything over here. The Z current section, as I said in the beginning, we're not going to be using a Z current because this is only for a homing current, and we're not using a stall guard system for the Z and the Z2, so we just leave those as they are. If you think about the Z axis as a mechanical unit, it's actually driving a fair amount of weight around. It's got to drive the axis up and down, obviously, but it's also carrying the weight of the X and the gantry that's all connected to the X. So I found 800 to be a fairly decent value. You can set these things down via G-code if you need to, but just for now and for all intents and purposes for this video, I'm going to leave those defaults as they are, just because I have tested them and they do work as a default. So and that's pretty much it. So let's just quickly have a quick squiz at this here. So just so we can recap, and like I said, I'll put this document into as a link in the description below, just so that you can follow along with it. We've already defined it, so we'll go through the whole thing with sensorless and with stall guard, with the dual Z. So initially we defined the sensorless homing. We set the 2 values in Marlin to 80. 80. We're going to leave all the rest home. What we did do is we uncommented the define homing, so we'll remove comments for that one. In the has trinamic section, we set the X home value. So we've set up the X current for home on X and Y. We set up the bumping, and we removed or edited the values from 5 down to 0 because we don't want any bump on stall guard. And that was done. I will also add in here M914 to check so we'll 914 to check up those values that we've just set up so that you can see what they were. Also the M122 to check current status. Of the drivers. Okay, I'll just leave it. I'll edit it before I put it back up for you guys. In order to set up the dual set, we've gone to and we've set up the commenting in front of defined dual step Z driver. Type is TMC2209. Just simply because those are the values that we're going to be using for this driver. Change the value. Set the number of drivers. Importantly, you must do this, otherwise you won't have that second driver initialized. Is define the number define numz underscore steppers 2. define LED Z. We're going to go back and do this in a sec for you. So this Z stepper align is that's going to actually give us the function in Marlin which allows that Z stepper align. And effectively what all that it is it'll pick a couple of points on your board, on your build table, closest to where the Z gantry is. So on the, if you drew a line across your Z gantry on the board when it's at home, that's the point that it's going to try and set up for you. So if we go back to Marlin and we do a search for that Z stepper align, this is going to then, if you look at this, the diagram over here, it'll show you where it's going to do that alignment. We're looking for the 2-stepper driver value. So if you thought of this here as the back of the build plate, and then whatever's in front here, it would be the front of the build plate. Those 2 points there are the 2 points that are closest to the stepper Z screw motors, and that's where it needs to pick up those values from. And it's going to basically use your BL touch or probe, and it's going to probe those 2 points on the bed, and you can set how many times you actually need it to probe. So you can set it in so it probes once or twice, and it goes backwards and forwards, keeps probing to find itself a value, and it'll take the 2 closest values, I believe, and it creates a value that if, let's say, the left-hand side of your gantry was slightly higher or slightly lower than the right-hand side, Marlin will then adjust that variance throughout the print process, and it'll save those values. So if defined Z stepper align, so that's basically going to say that the value or the actual Z stepper align process or function will then work. So anywhere else we need to set the amperage, we see it in these values here, we can just leave them alone. I found that they've worked okay. That Z stepper align iterations tells you how many times when it goes and does the align. So it'll start on the left hand side, go across to the right hand side, come back again, and that stepper align iterations will tell it how many times to do it. And I think it makes sense that the more times it probes, the more reliable that value will be. Define home after G34, we can leave that as is, and that's pretty much it. There's another value. Okay, so that's it. I just want to make sure that when you set up your printer as well, that the bed center for your printer is actually set correctly, so that when you do the homing position, it'll automatically return to the correct position on the home. And I think that's pretty much it, guys. I mean, that's Z Auto Line and Sensorless Homing or Stall Guard. Like I said, I will make this document I've created available to you guys as a downloadable link, so you can download it and then just follow on as you need it to. I think, unless. So let's. I mean, I'm already here. So if anybody has any questions they'd like to ask, or if there's anything that you're unsure of in Marlin that you might want me to just run through quickly, then please use this opportunity to ask me whatever it is you need. I'm quite happy to be tested on my knowledge right now. I won't say I know everything there is to know about Marlin, but I've been working on Marlin for a couple of months now, setting up my own machines. I've got a couple of machines, and been playing with things like 2-color printing, and I'm busy building a Prusa Bear clone, which I'm pretty excited about, and I might have some videos about that. But like I said, if there's anything that anybody in the live stream at the moment wants to know about as far as Marlin goes, or setting up the Skr1.4 board, now's a great time to ask. Is anybody actually still watching this? Just give us a thumbs up or an emoji. Tell me that you guys are still watching. If you need any more information. If not, then this has pretty much covered my live stream of how to set it all up. I'm not sure if there's anything else that you guys want to watch. Actually, one of the things that I can do, and I guess I did miss it, in this 914, when we're doing the thresholds, let me just show you quickly how to, if you needed to edit those values. So, like I said, and I showed you guys just now, the 914 basically just brings back the homing sensitivity values. In order for you to change that value, let's say we wanted to change the sensitivity on X, we need to do both values. So, if we wanted to only change the one, we can say X is 82, and then Y is, let's just say 70 for this, just to show you that it works. Click on enter. You then do an M500, which is a save command, stores that setting into the EEPROM. Now that setting is not actually active yet until you tell Marlin to load that setting into action, and that is the 501 command. So if you then went through this here and you had a look at all the values, so it's telling us things like the mesh slot that I've used on my mesh leveling is on slot 1 active, all of the PID settings, your extruder settings for your E-steps value is up there, my Z offset value is in this, so this M501, and then also if you wanted to read everything that's in the EEPROM back to yourself, you can use M503 and that'll do the same thing. So what's going on in your EEPROM, or what you have saved in the EEPROM, then you can always come back in here and use those M501 and M503. If you wanted to clear your EEPROM completely, there's sometimes you might have just flashed your firmware and you get an error which says incompatible or different type of or different EEPROM, or a value that's not. I think I can't even remember what the value, the error message itself is, but if it tells you that you have the incorrect EEPROM, then you can type into your system to do a M502, and M502 basically then just deletes everything out of the EEPROM and starts again. So you would do an M502, M500, saves the PROM, and then an M501 to load the Marlin default settings back onto the machine. So then anything that you changed before that will basically be lost, and it'll load all of the default settings that you've compiled into Marlin back into play. And then if we want to do, let's say, do a 914 again, we can then go back and say M914. We know that the values are set to 8 and 70, which we did just now. We saved it using the M500 command and then loaded it into play using the M501 command. And that's what it will use until such time as you either erase the EEPROM again using the M502, or if you went and hard-coded those values like I showed you in Marlin, where you can set those two values in Marlin, and then you wouldn't then have to use the M914 command to change the values if your system was all working correctly. So what I would suggest to anybody who's doing this is to make sure that whatever it is that you're doing works correctly, that there's no, and test it for a couple of hours or days or however you want to do it. But then at some point in time, go back into Marlin and hard code that value into Marlin, so that if something happened and you lost your EEPROM, that you're not going to be left in the dark and with a machine that you can't remember what the settings were, and you can go back and frustrate yourself again right from the beginning. And that can be quite daunting. If you look at the M503 command, I mean, it brings back so much data, and if you had to try and remember everything that you'd set via G-code through the Pronterface or whichever code editor you're using. And there's a lot of things that you can set in here. Like I said, you can set the E steps via G-code. You can set your Z probe offset. I expect that some people will know already how to do that. The driver stepper mode is another one of these things that you can set. So the M569 command tells you what, whether you're using stealth chop or spread cycle on whichever drives, and this is actually quite a good thing to check as well. So using the M569 command tells you what the stepper driver is actually working. But if this is quite important if you're using the dual Z, and you've set up dual Z correctly, that dual Z actually shows up in this when you do the M569, and it'll also do it when you do the M122. So it'll show you, that it's testing those things, and that each one of those drivers is actually sending back the telemetry as it would be expected to do. And in the case of the dual Z driver, just come back and do that M122 and make sure that drive is actually being recognized as a driver. Sorry. So, yeah, that's pretty much it for that. Like I said again, the dual Z driver is one of those things Prusa do it slightly differently. When you do a Z align on the Prusa machine, the X gantry will actually go to the very top of the gantry, and it actually it tops out on the X gantry, and while it's up there, it aligns itself, and then it sets it to perpendicular or parallel, to your build plate. And then that's how Prusa does it. But when we're using in this particular setup that we've got, it's going to use your probe, whichever probe you've used it. In my case, it's a BL Touch, and it'll use the BL Touch to go probe that left-hand side and the right-hand side at the two closest points on your gantry, and then it works out those figures, and then it saves those. And whenever you do these sort of configurations for Z Auto Align and the G code for them, always remember to do an M500, M501, so that it saves the settings that you just had. The same again happens with unified bed leveling or any bed leveling of that sort. Once it's gone away and done the bed leveling, make sure that you enter that M500, save whatever's just been done, and then load it into play using the M501 command. So I'm not really sure if there's much else that I can talk about as far as stall guard and Z Auto Align or the dual Z stepper drivers. Everything that I've covered in the video is, as you can see, they're all pretty simple things to configure in Marlin. But they can, in the case of the thresholds for the stepper drivers, is the only really tricky part of this whole process. And unfortunately, there is no happy number or happy figure that I can give you that's going to make your machine work or make the threshold on your machine correct, it could be, it then probably are pretty different on all machines. And I've tested this. I've tried seeing if I could use somebody else's values, and it's a case of you just being able to go through it by yourself. Keep going back through that M914 command, keep changing that value, whether it be up or down, and then, you know, just to make sure that you find that lucky or magic number that works for your machine specifically. Cool. So, you know, not much more than that I can tell you guys, just other than thank you very much for joining the stream. I hope this helps anybody. I hope this makes sense. I've tried to cover it in as much detail as I could, or as much detail as my limited knowledge of Marlin is, and hopefully, you know, this will help somebody. So yeah, I'm grateful that you guys could make it, and unless I will leave the chat open for a couple of minutes, and then if anybody has any questions, like I said, please feel free to ask. I've got a bit of time if anybody needs to know anything, and then we can, you know, I will cover whatever it is that you guys ask. If not, leave your questions in the comments, and if you want me to do videos on any other topics to do with Marlin or 3D printing, please feel free. Just, you know,